This video is about class width. There's a lot of confusion about class width when you study this in Chapter 2.1, and what happens is that there are two conditions for class width. Sometimes you're given the classes and they're listed, like this is an example where it says tar here, and there's another example I'll show you in just a few minutes that where classes are not given and you have to set up the classes. So if the classes are already given to you, what you're going to do is you need to just subtract these numbers. This is called the lower class limit, the 10 is, and the upper class limit is 13, and this is the frequency, and that 1 should actually be over underneath frequency. And then the second class, the lower limit is 14, the upper limit is, class limit is 17. Here the lower class limit is 18, the upper class limit is 21. And so down here I've written a note to you that 14 and 10 are the lower class limits. This is for class 1, 10 is for class 1, 14 is for class 2. And what you do is you subtract these two numbers. So you'll say 14 minus 10 gives you a class width of 4. Or you could do the upper class limits. I could say 17 minus 13 is also 4, and the class limit is the same using the upper or the lower class limits. And what you're actually doing is you're counting the numbers in each class. For instance, how many numbers are in this class? There's a 10, 11, 12, and 13. There are only 4 numbers in that class. You do not subtract this way. You never subtract on the horizontal axis. You subtract vertically, 14 to 10. You always subtract from class to class. The other one is when the classes are not given and you need to find the class width. And this example is example 1 in section 2.1 in your textbook. And it's the data is from 50 minutes spent on the internet, or from minutes spent on the internet by 50 internet users. And I've listed the 50 internet users. And what you're going to do is you're told that you want a class 7 classes. Sometimes you're not told how many classes you want, but this textbook is pretty good about telling you that. And what you do is you never have less than 5 classes and you never have more than 20. And in this example you're told that you want 7 classes. So I use this formula that's in your book, and it's the range, maximum minus minimum, divided by the number of classes. And the maximum and the minimum are highlighted in yellow here. The maximum is 86, the minimum is 7, and the number of classes is highlighted in green. And so you'll see here that 86 minus 7 is 79. You divide that by 7, which is the number of classes that you want, and that gives you 11.29. Now in most statistics books, what they do here is no matter what this number appears to be, you round it to the next whole number. So in this book you would round 11.29 to 12, and I know that doesn't make sense to you. Our book says to go to the next convenient number. Well, the next convenient number is a whole number here. So you don't do your typical rounding. You just take it to the next whole number. And this can kind of be tricky because 9.2 would go to 10. If you have a whole number 9, that also goes to 10. And then if you have 9.7, that also goes to 10. So all 3 of these numbers go up to 10. So my class width for here would be 12 because 11.29 would go up to 12. And what you do then is you build your lower class limits. You say 7 plus 12 is 19. Plus 12 is 31, plus 12, and so on. And then you go to this side, your upper class limits would be less than this one. It wouldn't be 19, it would start at 18. Add 12, add 12, add 12, add 12, and when you get down to this last one, you've got to add 12 to 78 to find out what this last number is going to be. Your class width should always be the same number between each lower class limit and each upper class limit.